Hi everyone, welcome to STEM Futures. So this is my second video in my series going through a shadow paper. This is based upon the 2018 Paper 1 Higher Physics. And these are unique questions. Some of them, the numbers have been changed and the wording slightly, but essentially it's the same idea, but it will give you some extra practice if you've run out of the actual past papers. Okay, so question 2 then. We've got a teacher using a Geiger Müller tube. A counter has measured the count rate from radioactive material sampled over a 60-second interval. So the counter has recorded 714 counts in 60 seconds. The background radiation count was 0.25 counts per second. Calculate the corrected count rate for the sample. We're given the equation, so use the equation. Corrected count rate is equal to total counts over time, or divided by time, and then subtract the background count rate. Okay, so we'll start off by finding our essentially writing out the formula. So corrected count rate. I know it's up there, but it's good to just follow along underneath. And I'm going to slightly change it just to use a fraction. So total counts over time, and then minus background count rate. Okay, so we have total counts is 714. Time is 60 seconds. Our rates are per second, so we're good with keeping it seconds. And then minus 0.25, which was our background count rate. Okay, so using a calculator, that gives you 11.9. Subtract 0.25. Again, using the calculator, will be 11.65, and that is counts per second. So if I fill it in on the answer line, there we go. So that's 2.1. Our marks are, roughly speaking, for this part here, the calculation of 714 over 60, and then for showing that we're going to then subtract 0.25, and the third mark is for a final answer. Okay, on to 2.2 then. So a 1 kilogram block of basalt has an activity of 900 becquerels. A kitchen worktop made from the basalt has a mass of 150 kilograms. Calculate the activity of the worktop. Okay, so there's a couple of ways of doing this. I quite like using a proportionality table. So we put kilograms on one side, BQ on the other, and then we've got 1 kilogram is 900. But what I actually want to find out is 150. Give a little bit of space there. Now, essentially, a proportion table just works that you keep things in proportion by either multiplying or dividing by the same as we go down or up or left or right. And in this case, we're going down the table. So 900 times 150. Again, calculator gives me 135,000. So all the actual calculation we've done, you can just write it out as a calculation, but the table helps just to make sure I'm going the right way. But that's the calculation we've done, just to make it extra clear. So there's our final answer. So with this, we've got 2 marks. 1 mark is for the calculation, 1 mark is for the answer. Okay, 2.3. So here we've got a lot of information. So the average total radiation dose per year is 2 millisieverts. Sieverts, I could never pronounce that. And the table below shows the effects of radiation on the human body by dose. Okay, so we've got some information in there. Then the next part is, the information for our actual calculation. So the average radiation dose from the worktop is 0.004 millisieverts per day. 1 year is 365 days. Explain why the householder should not be concerned. 2 marks. So we've got 1 mark is for calculating the year dose due to the worktop. So year dose is 365 days times by 0.004. Again, using a calculator and my notes, 1.46 MSV. So, I mean, it was clearly going to be way less than this 100 up here, which is our lowest dose of evidence of causing cancer. So we need to state essentially that, so since it seems a little bit obvious saying that 1.46 is less than 100, but it is, and the fact that it's significantly less is useful. But all we need to state which is the lowest dose. So I've said 1.46 is less than 100, which is the lowest dose. I'm now just repeating essentially what it says in the table. Lowest dose with evidence of causing cancer. Thus the householder should not. Thus the householder should not be concerned. So, I mean, I've written quite a bit there, to be honest, but you want to keep things nice and concise and exact. I mean, I have, repeated something in the table just to make it nice and clear. My marks are coming from calculating the year dose and then my statement. That's a nice clear statement. They're going to have to give you the marks if you're that clear. Okay, the final part of this question then, 2.4. Some communicators suggest that expressing small doses in banana equivalent dose, BED, suggest one reason this may help the public be more aware of radiation risks. It is only 1 mark, so there's not much to do. They're giving you 2 lines here. So the BED dose allows people to easily understand the risks, by comparing to an everyday object. And there's your mark. Okay, that's the end of question 2. Thanks for watching.